By a simple mechanical device, this toy mouse can sense when it has reached the edge of the table and alter course just in time to avoid falling off. Mechanical toys endowed with the illusion of life. They fascinate us. Man, who designed these simple toys, can design an artificial man that will one day surpass its creator. So says Dr. Isaac Asimov, scientist and author of science fiction. The robots of today, he says, are crude and mindless compared with those that will follow. They crawl ponderously about in laboratories. They toil without respite at the dangerous and tedious jobs that men no longer deign to do. They have only just begun. For the unconvinced, Asimov has more examples. The first step toward a true robot, he says, is a machine that greatly magnifies a man's physical force. Such machines now exist, long after they were described in science fiction.
Oh, here's a quote right here. Here is how it works. A mass of pressure receptors. You push, the suit feels it, amplifies it, pushes with you to take the pressure off the receptors that gave the order to push. The suit has feedback, which causes it to match any motion you make exactly, but with great force. Controlled force. Force controlled without your having to think about it. You jump, that heavy suit jumps, but higher than you can jump in your skin. That is the beauty of a powered suit. You don't have to think about it. You don't have to drive it, fly it, con it, operate it. You just wear it, and it takes orders directly from your muscles and does for you what your muscles are trying to do. Now, that's from a novel called Starship Troopers by Robert A. Heinlein, published in 1959, portraying a future that was moderately in the distance. And here we have a quotation from a manual put out by General Electric for certain materials handling devices. It says, with the man-made control system designed, the operator's natural arm movements are reproduced and magnified by the machine. Movement of the control handle causes the boom to duplicate the movement of the operator's arm. Now, it sounds very much like that which Robert Heinlein was describing in his story.
Still closer to the fictional power suit is General Electric's Hardyman. The machine is beginning to enclose the man, pairing mechanical force with human reflexes. Another GE invention is Quadruped. Duplicating the movements of the operator's hands and feet, it can apply great force. More important, Quadruped knows its own strength and is capable of great gentleness because the operator can literally feel whatever resistance it is meeting. The Quadruped was developed for the United States Army as an experimental vehicle for rough terrain. Only one Quadruped exists. It is currently dozing peacefully in a U.S. Army warehouse in Detroit, the temporary victim of a budget slash. The technology that went into its creation is available for future applications. The interfacing of this technology with a more advanced one will bring us that much closer to the realization of a mechanical man.
All these machines, marvelous and ingenious though they may be, serve only to augment the human muscle. It is the human muscles that guide these machines, and the muscles are in turn guided by the human brain. In order to have a true robot, you have to have a machine which is controlled by a brain of its own, which could, one way or another, augment the human brain.
Not long ago, NASA was testing just such a device.
In the exploration of other planets, if we can be helped out by automatic equipment of any kind, so much the better, because these planets are difficult to reach and difficult to be on. Mars, for instance, men can land on. Nevertheless, it would be awfully convenient if you can use something like a Viking lander. It can come down from a mothership, and while it itself doesn't move, scoops go out, dig up material, bring it back, treat it properly, analyze it, send back the data. It's what we might call a primitive, non-moving robot. Naturally, we look forward to a time where these devices are continually made more sophisticated so that it can do more accurately, with less constant direction.
This is the Unimation plant in Danbury, Connecticut. Another Unimate has just been born. And here in test bay number 1, it is limbering up its one good arm. Fairly bursting with eagerness to get out in the field and take on all those odious jobs that men detest and perform so unreliably, Unimate is working out, demonstrating to its creators that it can and will repeat endlessly a complicated cycle of motions. Unimate cannot learn in the sense of profiting from its own mistakes, but it can do exactly what it is told. It has a computer memory. Using the teaching gun, the programmer moves the arm and hand through the desired motions to the desired position. If he then pushes the teach button, Unimate will remember that motion precisely to within a few thousandths of an inch. It will perform a cycle consisting of hundreds of individual steps over and over and never ask for a break.
We might ask ourselves, why would we want a robot in the first place? It's a difficult object to construct, be fearfully expensive, especially to begin with. What would we get out of it? Well, society is filled with work that must be done. Some of it is highly dangerous, and it might well be that a robot could replace manpower there to work in deep mines, for instance. In fact, he could work under conditions which would be too dangerous for human beings. We could leave out some of the precautions we take. He wouldn't be breathing. He wouldn't have to worry about poisonous gases. He could work perhaps in the neighborhood of radioactive materials for considerably longer than a man dare to. And then it's not even just danger, the high temperatures, high pressures. It could be just tedium. There are many jobs that are fearfully tedious. A robot could work without boredom and be just as efficient after 24 hours of forever picking something up and putting it down.
The most sophisticated robots are not on the job yet. Here at Johns Hopkins University, a robot was developed that gropes its own way down the halls. If it is hungry, it can find for itself the only kind of meal that really fills a robot up: a few watts of household current.
It's one thing to have a machine perform exactly what you tell it to do. At the next stage, the programming itself can allow for flexible behavior on the part of the machine. Having done something which is, well, it's difficult to say wrong, having done something which is useless, is unsafe, is dangerous, it is programmed to recognize that and to do that no longer. It can distinguish those motions, those actions which are useful from those which are useless or dangerous, so that as time proceeds, it gradually makes less of the useless, dangerous motions, more of the useful ones. It adapts itself to its environment. It learns, if you like. Probably this is very much what human beings themselves do when they learn, except that at our level things are much more complex. And for a good long time, we'll be dealing with robots which, compared to human complexity, are simple indeed. Nevertheless, there will come a time when they will be able to learn, and they will end up doing more than we have originally programmed them for. And we have to take that into account too. We have to ask ourselves, not only what will this robot do, but what will this robot eventually do? And if we learn to ask questions like this, we may be asking them as the robots get more and more complex, until finally we're facing the possibility of mechanical life. There is no theoretical limit whatever to how complex robots can be and how close to human intelligence they can come. The human brain is made up of atoms and molecules and nothing else. And if we can invent a robot which has a brain that is made up of units as small as those of the human brain, as complex as those of the human brain, and is as intricately interrelated as those of the human brain, you will have the equivalent of the human brain with everything there is in a human brain.
For some years, men have been programming computers to play games against their inventors. This confrontation is taking place at Columbia University. The man on the right is playing against the machine. The man on the left informs the machine of its opponent's moves and carries out the machine's battle orders.
The computer will examine all its possible moves and ring a bell every time that it finds that it has no way to save its pawn or knight or bishop. A real panic situation. The computer cannot learn at this point. In the context of what people would define as learning, there's no chess program in existence that really learns. A Stanford professor, Arthur Samuels, wrote a checker plane program which learns to a certain degree. The checker plane program right now is as good as the state champion, roughly, of Connecticut. But chess is much more complicated than checkers, and nobody has attempted to build learning into chess programs the way they have into checker programs.
The end game, the critical juncture. Man ponders his options carefully. Machine bides its time. Man moves. Rook to queen one, a brilliant move. Machine, informed of man's masterful stroke, ponders its own options and quits. But robotics experts are convinced that he will someday win every game.
And there's no reason why you stop there. Once you build a robot that complex, you will undoubtedly, with that robot's help, be able to build a still brighter robot or computer, since we're talking about the brain. In fact, I once wrote a story called The Last Question, in which I traced the gradual development both of the human race and the computer together through the next trillion years, or 10 trillion years. And in the end, the computer had literally become God. And when the universe ran down, the computer said, "Let there be light," and there was light, and the whole thing started again. It was purely a work of the imagination, but I'm willing to stand by that. There is no limit. In the short-range future, I suppose there might be a drive-on to develop robot-like devices that can do housework. If we continue with our desire to liberate women, to get rid of this half the human race that are slaves of the other half, someone is going to have to do the housework. And the robot who can do that would be great. Robots, or mechanical men, have been one of the stock interests in science fiction. From ancient times, even before it was properly speaking science fiction. There's something attractive about having some sort of mechanical man under your control. It's the next step up from controlling a demon. But always there was the impression that this was dangerous. It was the kind of knowledge that was too risky, like trying to control a demon. So that the classic robot plot is that of a man who devises a robot which then kills him. And only in the late 30s did we get away from that and begin to write stories in which robots were machines and not diabolical demons. I wrote a series of robot stories in which robots were looked upon that way, purely mechanically, and in which I had the I imagine novel notion that robots, like other machines, would be built with safeguards. I mean, nobody would manufacture a knife without a handle to hold it by. And it's ridiculous to assume that if you were capable of building a robot, you wouldn't be also capable of building it with certain set procedures built in that would keep it from killing you. So I invented the 3 laws of robotics, which I always used in my robot stories, and which these days other writers use too. Not explicitly, they don't quote them, but they use them implicitly. They take them for granted. They are: 1, a robot may not harm a human being or through inaction allow a human being to come to harm. 2, a robot must obey orders given it by a human being, except where that would conflict with the first law. 3, a robot must protect its own existence, except where that would conflict with the first and second laws. Well, I wrote a series of stories, and novels too, based on robots following these 3 laws. And in my early stories, I spoke considerably of man's Frankenstein complex. They didn't trust the robots. They feared the robots. They somehow had this feeling they would be replaced by robots. So that there were laws against using these robots of mine on Earth, and mostly they were used on other planets under conditions where humans could not work. However, there were not only these robots proper, which are man-like in appearance and move around like men, but there are also the isolated brains of robots, which, because they exist in themselves and don't have this human-like appearance, are less frightening. In short, in addition to the robots, there were advanced computers. I wrote these stories in the 1940s, before the electronic computer had been developed, you see, so I didn't call them a computer, I called them brains. And in my later stories, these brains control the Earth. In fact, the brains had reached the point where, even if a human being nominally in control of one of the regions of Earth were to give an order, which in the estimation of the brains was unsafe, dangerous, it would not follow. It would do what it considered right. In short, man had lost control, and rightly so. Man could no longer control it safely. It had to be controlled by these mechanical brains. In fact, the brains, in disobeying human orders, are taking into account human resistance to the takeover, so to speak, by the brains. They are allowing for human distrust for the machine, human anxiety to make this intuitive jump, which may be unsafe. And the question is, you know, how close are we to that sort of thing? In a way, we rather are in it now, because the bureaucracy has to have a life of its own. It works up a kind of inertia. It can't be lightly manipulated. We elect presidents, we elect congressmen, but in the end, no matter how we change, there is something about the details of all the bureaus and all the departments that keep right on going.
Dr. Isaac Asimov has written of a fictional future when machines assume the direction of society, and they do so in such a way as to leave man with the illusion that he still directs his own affairs. Is it possible that this fictional future has already arrived?
However, the real thing is that I have pictured in my stories the control of society by mechanical brains, even though in my story I placed it at little more than a century in the future. I think it'll take a long time yet before that happens. But I'm sure that's a long way off into the future.